All right, reached our 10-minute limit there, and so we pick up where we left off in our screencastify here. So we left off with solving for x. We've got to move the x's onto the same side of the equation. So we could either move the 5x to the right or the 3x to the left. I'm going to move the 3x by subtracting. Hopefully you would want to do the same thing. Because what that does is gives us a positive value over here. It cancels it out from the right side. So we have our 2x minus 7 is less than 11. So no flipping because we didn't multiply or divide by a negative. Next thing, all right, so now we're getting kind of similar to the question we had before. So working our way back to the x. Next thing that we will undo is that subtracting of 7. The opposite is to add 7. So we'll add 7 to both sides. 2x is less than 18 then. 11 plus 7 is 18. And then this is 2 times x. The opposite of multiplying to undo it would be to divide. So we have x is less than 9. For our solution. Again, we don't have to graph that one, so we'll just leave it as x is less than 9. Our last topic for our little mini assessment today is to graph a two-variable inequality. Notice now we have a y and an x, which means when we graph it, we don't have a number line anymore. We have a coordinate grid system with an xy axis. So now let's just think about how we graph a line. Think about when it's in slope-intercept form, what is your slope? What is your y-intercept? A y-intercept is a point, so we graph that first. The number that stands on its own, that is not next to the x, is our y-intercept. So in this case, our y-intercept is positive 3. Positive 1, 2, 3 on the y-axis is right there. Now let's think about our slope here. Our slope is negative 1/4. Put the negative with the numerator for this purpose. And so when we think about our slope, let's think about our rise and our run. So we're going to think about our change in y divided by change in x. So our up-down amount is the negative 1. So from our y-intercept, we go down 1. And then our run is our side-to-side amount, and it's positive 4. We always make our run positive. There are some situations in which we might consider making a run negative, but I usually put the negative with the numerator. And so now we have our line, but before we graph our line, remember this is what's different about an inequality. We now need to think about, is this line going to be solid or dashed? In other words, are the solutions to the inequality xy going to be on the line, in which case it's solid, or not on the line, in which case we'd have to make the line dashed to represent that. Since this does not have an equal sign, that means that it's a dashed line. The points on the line are not going to be solutions. So those 2 points that we graphed and all the other points on the line would not be solutions to this inequality. Where are the solutions? Well, the solutions were indicated by the type of inequality. This is a greater than, so shade above. Above the line is where all of our solutions will be. Use a different color. So up here would indicate all the possible x, y values here, 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 that if we plugged in for x and y in the inequality statement would make a true statement where y would be greater than negative 1/4 times the x plus 3. So we represent that, and there's a whole bunch here going into infinity that we can't indicate with our shading, but everything above what we have shown here in our window would work. All right, last question here. Similar to the previous one, let's just repeat those same sort of steps. So once again, let's think about our slope and our y-intercept, slope-intercept form. In this case, here's our y-intercept standing on its own here, but don't forget it's a negative 3. That subtraction sign goes with it. So negative 3 is our y-intercept. Let's graph that point first. And then let's think about our slope here. Now our slope is 2. And as a rise over run, remember, if it's a whole number, just put it over 1, as 2 divided by 1 is the same thing as 2. But it helps us think about the vertical change versus the horizontal change, the rise versus the run. So let's go ahead. Both are positive. So we're going to rise positive 2 for our y-intercept, and we're going to run positive 1, which means to the right 1. You want to repeat that pattern a couple times you can. Let's take a look now, just like we talked about before. Before we draw in our line, is this line going to be solid or dashed? Well, in this case, our line has our inequality symbol has an equal sign. Okay, so that means that the points on the line will be solutions. So we're going to represent that with a solid line. So in other words, just like a line that we normally would graph with the regular equation. So that means the points on the line are solutions. They would work. They would make a true statement. In addition to that, a whole bunch of other points would make true statements. In this case, since it's a less than or equal to, so less than or equal to, key is the less than now. So shade below. All the solutions would therefore be below the line, and so all of those points, if we took and plugged them into our inequality, would make true statements. That's what we have for our review here. So hopefully, if you needed to pause that at all to finish up the graphing, go ahead and do that. If you need any explanation or rewind, go ahead and do that. And now, for many of my students, we'll move on to an assessment that looks very similar to this. So keep that out.